Okay, welcome back. Um, welcome back. So example 3 here, just I'm still focused on free body diagram. This is like a piece of wall. Let me whether I can draw this in 3D. A piece of wall, and then you have some cylinder that is lying in it, or a piece of wall then with a ball, a sphere. So he's making a contact here. It's also make a contact here. So what you see here is like a section, a cross section. Okay, that is like a cross section. So we need to draw the free body diagram of the sphere or the cylinder. Okay, whilst it's making contact here. For now, let's say we are neglecting friction. If you are, yeah, let's say we are neglecting friction. All surfaces are smooth. All surfaces are smooth. So free body diagram, as I said, you disconnect or you detach. You draw the object which is detached from the other objects. So the other surfaces are this and that. So we're going to detach this. So we draw the ball or the sphere on its own. Okay, on its own. When we finish, let's say the angle here is like what do you want to do? 60 degrees. That's the angle here is 60 degrees. So what I'm going to do is that I'm not going to draw the surfaces, but I'm going to draw some lines here, just for to show the contact surfaces. Okay. So there is a weight of this coming down. The weight always come down. That is mg. And then contact, there is a reaction force here in between here. So this will react to that. The surface will react, give a reaction force. The same thing is happening on the other side. No, I didn't kind of struggling to draw with my marker here. So there's a reaction force, like similar to what is here. So if there was a friction, then there you have to draw opposing friction. But let's assume there's no friction here. Well, let's do something. Let me draw some horizontal line here and some horizontal line here. We should want to transmit this angle to it. So let's say this is symmetrical. So if you draw a line here, then that is 30 degrees. That is 30 degrees. If I draw a line here, if this is 30 degrees, then that is 60 degrees. So if I make a line here, I don't know whether some of you know, if I make a 90 degrees line here, okay, then if you have something going this way, I don't know how best you can wait to see this, because this is 90, so this is 30, and this have to be 30 degrees, okay? So if you that is the case, this will end up 30. You can figure out this later on, 30, and that is 30. Somebody can also show this angle, the angle to the, let me do that one here. You do this, you show the surfaces, and then you show the reaction force, the 90 degrees to it, perpendicular to the surface. So somebody can also show this angle. Because you can draw this like this, and then you can also drop a line like this, this line. If you draw that line, then this angle will be 60. You can go and check this out. This angle should be 60. So at least you should to transfer whatever angle was here into your diagram. You should to transfer that into your diagram. Okay, so this will be the forces that is acting on it. If there's a frictional force, then the friction force will go up. Okay, the frictional force will go up. Okay, so this just to give an idea how to go. Oh, I didn't label the forces. Let me call this point. I didn't label the forces. Okay, so let's call it R1, R2. Yeah, I have to label the forces. But if it's symmetrical and this surface is the same as almost the same, then it has to be R and R. They have to be R and R. Okay. Okay. So that's how to go about drawing free body diagram. Drawing free body diagram. We're now going to start working. Let me see whether I can work one example before this video work. Okay. So now we're now going to compute unknown. So we're going to start with 2D. Maybe I'll do 1D before I go to 2D and later we'll go to 3D. So we said in general, if a particle is in equilibrium, the sum of forces is O in general. And then that's in 3D. Then you can break into sum of forces in the X is 0, sum of forces in the Y is 0, sum of the forces in the Z is 0. If you are doing 1D, then it's like the particle is only lying on one line. So let's call the line X. So in scalar form, it's going to sum of forces in the X is 0, or the resultant force in the X is 0. If you are doing 2D, then you are in the XY plane. So the particle is lying in the XY plane. So remember, if a particle equilibrium means it shouldn't translate, or it should, if it's moving with a constant velocity, acceleration is 0. So if it's that, then the sum of forces in the X is 0, sum of forces in Y is 0. And so let's do 2D now, coplanar. Okay, 2D coplanar. Okay. Because something have to be 2D, then you have to be in the forces are in one plane. Okay. So I'm going to shoot to one note and I'll work example for A and B, and then I'll end this video. I'll continue again in the next video. So in example 4A, I've intentionally done the problem. That's a 1D. So if the particle is in equilibrium, this is the particle in equilibrium. You have a force F here and a force 20 Newton. They want us to find F. So these are already like a free body diagram is drawn, that have been drawn. So we're doing sum of forces in the X is 0, because this is the X direction. Sum of forces in the X is 0. So it means what? One way somebody can say F plus 20 is equal to 0. So F equal to negative 20. Okay. And F is showing, so it's negative 20 newtons that way. Or as I said, you can also say F is actually 20 newtons this way. It's up to you, the way you want to write. Normally, you want to state that. So that's how to go. Let's do the 2D. 2D, as you could see, is like normally nobody have an X and Y. So yeah, but you can take this side as your X and this side as your Y. So in a 1D, the maximum unknown you can have is 1. In 2D, the maximum unknown you can have is 2. So that's why you have 2 unknowns. So this is already like a free body diagram, and one tries to find F and T. So these are like some magnitude of forces. So your equation will be summation of forces in the X is 0. Let's apply that first. If you do that, you're going to have F here and then T cosine going here. But the question is that if you do that, you're going to have equation in that. And then later you go summation of forces in the Y. So you have 2 simultaneous equations you solve. But I want to say something. It's not all the time that you need to do X before you do Y. Always look at the problem. Always look at the problem. In this problem, F is only in the horizontal. T is diagonal. So T will have a component both in the horizontal and then the vertical. So it means if I start with summation of forces in the Y equal to 0 first, that is, I'm summing the forces, forces in the Y equal to 0. And let me say this is the way, I believe I've said this in class before. This is the way I sum forces, especially if the object is in equilibrium. Then I can say forces upward equal to forces down. Or somebody can say T minus 40 equal to 0. It's up to you. So I'm going to do that. So this is the cosine part and that is the sine part. So it means T sine 30 is equal to 40. That's equation 1. Okay, that's equation 1. But if you know sine 30, I believe is half. So T here is equal to, if you work it out, I believe it's going to be 80. I don't know whether I did this well. half if you divide to flip one, so I finish 80 here. And then you do, and this is what I said, you can also write it as t sine 30 minus 40 equal to 0, or 40 minus t sine 30 is equal to 0. It's up to you. The forces have to be balanced. So you can say the algebraic sum of the forces is 0, or forces this way equal to forces that way. And that's what I like to do. And then it says summation of forces in the x is 0. I like to put a semicolon here. We are not adding. It's not like when we used to find resultant. Here it's an equation. So what happened is that I'm just going to write f to the left, and then to the right is t cosine 30 degrees. And we already know t. T is what? 80. So this will be f equal to 80 cosine what? 30. If you want to keep it exact, no problem, because cosine 30 is as if root 3 over 2. So this will be like 80 times root 3 over 2. So that will end up like what? 40, is it 40? 40 root 3. You can keep it in that decimal, no problem. Okay, you can keep it in this, no problem. Okay, so that brings us to the end of this this video. Okay, that brings us to the end of this video. I will do the next one where I'm going to work more kind of examples, more examples. So I've intentionally picked 2 examples. It's like already the free body diagram is drawn. So this is 1D and that is 2D. So it's like we're taking our x on this side and our y here. And I don't know anything about positive x, negative x. I don't really know. Okay. There's a sum. I do forces pointing one side. So in this case, this arrow is going to the left, right? This arrow is going to, so I'll sum them. Okay. And there's nothing going to the left. That's why I put 0 here. But here, I do upward equal to downward. Then here, I did those to the left is equal to those to the right. And that's what I wrote here. And then you finish. Okay. So this video is ended. I'm ending it now. I'll record the rest tomorrow. Bye-bye and thank you.